Good morning, my dear students. Myself, Vijay Shankar from ECE Department, Chevrolet Engineering College. Today, we are going to discuss about the convolution and correlation examples. Already last two classes also, we all discussed about the convolution examples, the continuous time graphical representation and the discrete time graphical representation also. So today, we are going to discuss about some examples in the correlation and the convolution. So the first example, find the linear convolution x of n is equal to 105 and h of n is equal to 1 ohm. So without any arrow marks is given in the sequence, the first value is n is equal to 0, and here also the first value is n is equal to 0. So how many values will get for the y of n, the convolution of the x of n to h of n, the initial value for n is equal to 0 for x of n, and here the initial value n is equal to 0. So y of n is also 0 starts the interval, and 1, 2, and here it is a 0, 2. So three values will get 0, 1, and the 2 in the y of n. Follow my students. So the first value, draw the graphical representation for the given x of n is 1, 0, 5. 1 is at the 0, and 0 is for at the 1, and 5 is at the 2. Follow my students. See here the root is a n1 is equal to 2 and n2 is equal to 1. n1 plus n2 minus 1. The sequence starts at, I already explained here, it's the sequence starts at the 0 and ends at the 2. n1, how many number of samples are there? The n2 and the minus 1, the 2 plus 1 minus 1, the total is a 2. The total sample, so 3 plus 1 is a 3, my dear students. It is not the 2, 3. How many number of samples are there in this x? 3. How many number of samples are there in the h? 1 minus 1. This is a formula. The number of samples will get in the y of n, n1 plus n2 plus minus 1. Number of samples in the x and the number of samples in the second signal, h of n, minus 1. 3 plus 1 minus 1 is equal to 2. The range is a 0 to 2. And h of n having only the one value, and x of n 0 is a 1, and 1 is a 0, and 2 is a 5, my dear students. 2 is a 5. It's wrong here. It is a 2 is a 5. The given 105. And h of n is h of tau is equal to 1. What is the first to have to do? The h of minus tau. H of tau and the h of minus 2 both you can fold it at the origin only. Okay, there is no any change in this one. The positive relax is all the values 0, and negative relax is all it is a 0 zone. H of minus 1 means at n is equal to 0, but not the n. T is n only actually. N is equal to 0. Y of 0 is equal to. Y of 0 is equal to. Now you can multiply the two functions. As 0 there is a 1 value for x, and 1 is a 0, 2 is a 5. Here only the one value we have at 0. So 1 into 1 is a 1. Y of 0 is equal to 1. And next value n is equal to 1. N is equal to 1 means here the h of n minus tau. Adding the value 1 minus tau means you shifted towards the right side. One sample shifted toward right side. 0 is equal to 0, and now the value is 1 here. Okay. Multiply the two functions. X of tau, there is no any change in the x of tau, my dear students. X of tau is the same. One value here, the 0. 1 is a 0 here, but the value is 1. 0 into 0. 0 into 1. 0 into 1. The value of x is a 0 at 1. The value of H after the shifting one sample right side, the value is 1, 0 into 1 is a 0. When n is equal to 2, the y of 2 is equal to, still it is shifted towards the right side one sample, h of 1 minus tau, h of 2 minus tau. This one is a h of 0 minus tau. So what is the value here? The 5. 5 into 1. 5 into 1, 5. Okay. So y of 0 is equal to 1. Y of 1 is equal to, sorry, it is a value of 0.5, my dear students. 0.5, this one. I saying that is a 105, but it is a 0.5. Actually, it is a value is a 0.5 as per here. A small mistake I did. Sorry. This is the second point is a 0.5 only, my dear students. So 0.5. I think it is a 1, 0, 5, but here only the 1. Okay. Now, how many number of values will get the 2? It is a 2 only, my dear students. The previously I told that is a 3 because of 105. I think it is a 2 values. N is a 1, 2 plus 1 minus 1, the 2 only. The 3 plus 1 minus 1 actually you have to get is a 3. 0 to 3. But it is a 0 to 2 only. Sorry for that one. The value of y of n sequence it starts from the 0 to 2. What I explained now itself is wrong, my dear students. You see, this is a 0.5. Okay. So what is a n is equal to 0? When n is equal to 0, h of 1, 1 into 1, the y of 0 is equal to 1 into 1 is equal to 1. And n is equal to 1, 1 is a sample is shifted. So 0.5 into 1. Okay. 0.5 into 1 as it's a 0.5. And n is equal to 2. Y of 2 is equal to, now it is shifted. There is no any sample here, the 2, 0, 0 into 0, 0 only. Then after you can draw the graphical representation. Y of 0 is a 1. Y of 1 is equal to 1. Y of n is equal to 1. 0, 1, and the 2 is also there, it is a 0. Because I have to get the 3 samples. One sample is 1, and the one sample is 1, and another sample is a 0. The y of n sequence 1, 1, 0. 1, 1, 0. Totally 3 values, 0 to 2, 0, 1, and the 2. What it matters first. Then the next example is a graphical representation of the continuous time signal. Find the convolution of x of t. This is 0 to 2. And h of t is from minus 2 to 2. Minus 2 to 2. Not the 2, it is a 1, my dear students. With 1 only. Then take the same value. X of tau is equal to 0 to 2. H of minus tau. H of minus tau means the negative positive real axis will get in the negative real axis minus 1 to 0. And negative real axis will get in the positive real axis from 0 to 2. Okay. Now see, in where it is a overlapping occurs. 0 to 2 is a overlapping occurs. And the value is y of minus 2 is a 0 and y of minus 1 is also 0. And the y of 1 is equal to, y of 0 is equal to, y of 1 is equal to something. Now, whenever if I am taking these two multiplication factors, the first value is a 0 to 2. 0 to 2 here also. And here also the 0 to 2. Overlapping occurs. Okay. Whenever if I am taking 0 to 2, the magnitude is also given. What is the magnitude here? H of t is a 2 and x of 2 is a 1. h of t is a 2 and x of t is equal to 1. So whenever if it is a varies from y of 1 is equal to, I'm taking it as a y of 1 is equal to, when is equal to 0, h of a 0 value, h of 0, there is no any shift in this 2, h of 0, varies from the 0 to 2, 0 to 2, and here also the 0 to 2 is overlapping occurs. I will explain here. See, my dear students, the x is from the 0 to 2 and h is from -1 to 2. -1, 0, 1, and the 2. This is x of tau. This one is a h of minus tau. See, there is a overlapping is there for 0 to 1 when n is equal to 0. When n is equal to 0, y of 0 is equal to, what is the range here? 0 to 2 under the integral 0 to 2. Magnitude of x, h is a 2. Magnitude of x is a 1. So 2 into 1 into dt or the d tau. Dt let us take here. 2 into t with the limitations of 2 and 0. The value is 2 minus 0 into 2 is equal to 4. When n is equal to 0, we got the 4. You see here, when n is equal to 0, y of 0, 4. When n is equal to 1, n is equal to 1, the h of 1 minus tau. 1 minus tau means one sample is moved towards the right side of h. See, for the x is the same. Now, one sample is moved towards. So it starts from the 0 and ends at the 3. Because it is a 2 and one sample is moved towards the right side. 2, 1, and the 0. Now see, again there is a overlapping occurs between the 0 to 2a only. Here the 0 to 2 and now the overlapping occurs at the 0 to 2 only. Okay, but the magnitude is 1 here and the magnitude is a 2. So see 0 to 2, again the 4. Got it, my dear students? For the n is equal to 2, for n is equal to 2, the h value becomes a 2 minus tau. So one sample is added, means shifting towards the right side again. 2 samples. Already the one sample it gets at the 0. Now another at 0, it is a 0 only. Now it starts from the 1 and ends at the 4. Previously it is a 3. So 1, 2, 3, and the 4. Now observe here, there is a overlapping occurs between 1 and 2 only. Here the 1 is there, between 1 and 2. Okay, magnitude is a 2, here the magnitude is a 1. Now the range is 1 to 2, 1 to 2, limitations 2 into 1 into dt, 2 into 2 minus 1 is a value is a 2. Got it? Now still you can move towards the right side. Still you can move towards the right side, the 0, when the h of 3 minus tau. So the value is a 3. So y of 3. Okay. One sample towards the right side. So already it starts from the 1. Now it starts at the 2 and ends at the 5. So 2, 3, 4. Now compare here. The 0 to 2, the magnitude is 1. For here the 0 to 2, the 0 value is there. There is no any value in the 0 to 2 range. When you can multiply these two, you get the 0. So no overlapping occurs, the value is a 0. Whenever the y of 3, n is equal. Still you can see this from 0, we start from the 0 because the h of 1 minus tau and another one h of minus tau also we observed. That is for n is equal to 0, n is equal to 1, n is equal to 2, and n is equal to 3. Here the value is a 0 minus, 1 minus, 2 minus, 3 minus. Means one sample is moving towards the right side after folding. If folding occurs at the n is equal to 0. Still, if you can move after the folding, means folding is a minus 1, 0, 1 and the 2. Now I am moving towards the left side. Moving towards the left side means the value is minus 1 minus 2. One sample. These are centered here. 1, 2 and so on we are adding. Previously is the value is a 1 minus 2. H of minus 1 minus tau when n is equal to minus 1. But the movement towards the left side. My dear students. Now see, this is the h of minus 1, 0, 1 and 2. Moves towards the left side means it starts from the minus 2, minus 1, 0 and end at the 3 because it's a one sample towards left side means end at the 1. Okay, this is a h of minus 1 minus tau. Now see where it overlaps because of the x of tau is 0 to 2 and here the 0 to 1 the value is there. Now take this range. So 0 to 1, you see here 0 to 1, 0 to 1, 2 into 1 dt that is equal to 2. Still you can move towards the right side. One sample that is h of minus 2 minus tau. Is the two samples already the minus 2. Now you'll get it is a minus 3, minus 2, minus 1, 0, minus 2, minus 1. Totally the 4 samples are there. See, now you compare these two. There is no overlapping from the 0 to 2. Here the 0 value is there. And here the 0 to 1 is a 1. So 1 into 0, 0. So y of minus 2 is a 0. Y of minus 1 is a 2. So what is the sequence now? We'll get y of n is equal to 0. Minus 1 is a 2. And the 0 is a 4. So you can keep the arrow mark here. 0. Next is a 4, 2 and the 0. So before and after there is no any 0 value here. The 2, 4, 4, 2. The sequence is and arrow mark I am representing the value is at n is equal to 0. N is equal to 0. So see here at minus 2. There is a minus 2 here. N is equal to minus 2. 0. Slowly it is increases. N is equal to 1. The value is a 2 here. You see the 2. N is equal to 0. The value is a 4. It's a 4, my dear students. And then the n is equal to 1. The value is also 4. It is at the constant. There is no any slope. Up to this is a slope. Then n is equal to 2. The value is decreases to the 2. And n is equal to 3. The value is decreases to the 3. 0 value. Got it, my dear students? Like that we can, for the given any samples, either in the continuous or in the discrete, draw the diagrams, change the t as tau, and keep the signal, the first signal x of tau is the same, and take the second signal h of t as h of tau, and then folded h of minus tau, add the values from 0 to something, 0, 1, 2, 3, and so on, move towards the right side. If you can add the negative values, move towards the right side and see is there any overlapping occurs in the range. Is there any overlapping occurs in the range? Apply the integral. But in the discrete time function, you can follow the procedure the same, but you have to add the samples because the formula saying that is a sum of. But in the continuous time function, the convolution formula is an integral. So taking that, the wherever there is a overlapping occurs 0 to 1 here, taking the 0 to 1, overlapping occurs 0 to 2, taking the 0 to 2, overlapping occurs 0 to 2, taking the 0 to, overlapping occurs here the 1 and 2, taking the 1 and 2, and there is no any overlapping 0 and 0. Okay, it's actually 0 and 0, not the 0 and 0. These are 2 and the 2 also. 2 and 2. So upper limit is a 2 minus 2. 2 minus 2 will get the 0. Got it? So we did so many examples of the convolution as in the continuous time and the discrete time. So some of the properties we already discussed this one. Some of the properties we have. Commutative property. How we'll get the commutative property? See the formula of the convolution. X1 of t and x2 of t, the two signals we have. What is the convolution formula is integral minus infinite to infinite x1 of tau, x2 of t minus tau deta. T minus tau deta. We are saying the convolution obeys the commutative property. Convolution obeys the commutative property. X1 of t convolution with x2 of t is equal to x2 of t with the convolution of x1 of t. You know the convolution means AB is equal to BA, interchanging of the two functions. Now I am using the definition integral minus infinite to infinite x1 of tau, x2 of t minus tau deta. Replacing the t minus tau is equal to p and tau is equal to t minus p. And here the t is a constant and tau is variable and the p is also variable, because changing the integral of limitations, tau limitations to the p limitations. So in this, the tau and the p is a variables and the t is a constant. So d tau is equal to minus dp, and d tau is equal to minus dp. Here the minus d tau is equal to dp. When tau is equal to minus infinite, p is equal to t plus tau, here the infinite. For minus infinite it becomes of plus infinite. And the tau is equal to plus infinite, the p value is minus infinite. So changing the limitations from minus infinite to infinite as infinite to minus infinite. Here the value is minus is there. And change this minus here, and the limitations you can change from minus infinite to infinite. Okay. So whenever if you have the plus infinite and the minus infinite inside, when I'm substituting the x1 of what is the tau now, the t minus p, and the x2 of what is it, t minus tau is a p. And now what is a d tau is equal to minus dp, minus d into p. So change the limitations from minus infinite to minus infinite as upper limit as lower limit and lower limit as upper limit, means negative sign becomes a positive. So x2 of p, x1 of t minus p dp. Now what is a d? P is a dummy variable only. P is a dummy variable. Now it is equal to that of actual definition x1 of tau, x2 of t minus tau deta. The p is a dummy variable with the tau, and now see x1 is becomes of x2 and x2 becomes of x1. The commutative property x2 of x1, x2 of x1. Of means is a convolution here. The x1 of t convolution with the x2 of t is equal to x2 of t convolution of x1. Okay. And the distributive property. So what is the distributive property? You know the A into B plus C is equal to AB plus AC. Now if I am taking that x1 of t with the convolution of x2 of t plus x3 of t. So x1 of t with the convolution of x2 of t as one function plus, and this x1 of t with the convolution of x3 of t. Okay. So integral minus infinite to infinite x1 of tau x4 of tau. Since why I am taking this x4, already inside there is x1, x2 and x3. So this term only I am taking x4 of tau. So x1 of tau, x4 of t minus tau d tau. And integral minus infinite to infinite x1 of tau. What is the x4 of tau? The combination of the two signals. That is x2 of t minus tau, because the t is as a t minus tau, and x3 is t minus tau d tau. And integral minus infinite to infinite, split this as a two integrals. x1 of tau, x2 of t minus tau d tau plus x1 of tau, x3 of t minus tau d tau. Observe here the two integrals in the two terms. The first integral, the convolution equation x1 and x2. Second term, the two equations x1 of 3, x1 of tau and x3 of t minus tau d tau, convolution of two functions. Okay, whatever they in the parentheses x2 and x3, assume it as x4, then x4 and the x1 convolution definition you can apply here. What is the x4? Actually x2 and x3, and replace the t as a t minus tau. Multiply and write the two parts. The first part is x1 and x2 convolution. Second part is x1 and x3 convolution. And the distributive properties also obeys convolution. Convolution obeys the distributive property also. Next, associative property. We already said that is associative properties also obeys. What is associative property? As in the mathematics we know, A into BC is equal to AB into C. This is associative property actually. Here also I take the statement x1 of t convolution with x2 of t and x3 of t is equal to x1 of t with the convolution of x2 of t and the convolution of x3 of t. Okay. I'm taking here in the terms of n values, x1 of n with the convolution of x2 of n and whole convolution with the x3. Okay, so within the parentheses what we have, assuming that the y1 of n, y1 of n. So y1 of p is equal to, and let us replace the n by the p also. P is equal to, y1 of p is equal to x1 of p convolution with x2 of p. And I taken it is a n values, means the convolution is in the sum, discrete. Okay, discrete value minus sum of k is equal to, actually the k is equal to minus infinite to infinite x1 of k, x2 of n minus k. But what is the n here now? The p. What is the k here? M. So x1 of m, x2 of p minus m. Let y2 of n is equal to x2 of n with the convolution of x3 of n. I'm assuming the y1 is x1 and x2, and y2 is x2 and x3. So y2 of n is equal to sum of, here I'm assuming the q. Q is equal to minus infinite to infinite, x1 of q, x2 of n minus q. So remember this one, the y of n is equal to the sum of k equal to minus infinite to infinite, x1 of k, x2 of n minus k. So here the output is n, here also the output is a n. N, and this is also n minus. The variable here the k, and these two are the k values. Assuming here the y2 of n, x1 of n and x3 of n, taking the k as a q. Okay, x1 of q, x2 of n minus q, n value is the same. Now y2 of, I'm subtracting the m from the n, y2 of n minus m. The sum of q is equal to minus infinite to infinite x1 of q, x2 of n minus q minus m, q minus m. Okay, put it that two functions, y1 of p as one function and the y2 of n minus m. Now let us take the LHS here. LHS. What is LHS? x1 of n with the convolution of x2 of n with the convolution of x3. I assume the x1 and x2 as y1. So y1 with the convolution of x3 of n as sum of p is equal to minus infinite to infinite y1 of p x3 of n minus p. With this equation, the definition of the convolution, my students. Okay, the two values we have, sum of as a k, I'm taking here the p minus infinite to infinite. The first signal y1 of p, the second signal x3, so x3 of n minus p. What is the y1 of p? We know here this is y1 of p is equal to sum of m is equal to minus infinite to infinite x1 of m, x2 of p minus m is up to the y1 of p and x3 of n minus p. Okay, so rewrite this expression as sum of m is equal to minus infinite to infinite x1 of m and sum of n is equal to minus infinite to infinite p minus infinite to infinite x2 of p minus m, x3 of n minus p. P minus m and n minus p. So p minus m is equal to q. Therefore, p is equal to m plus q. Changing the values, my dear students. Okay, let's assume the p minus m is equal to q. P is equal to m plus q. So limitations here, the p values. I'm changing the p values to the q. So when p is equal to minus infinite, what is a q is equal to minus infinite? When p is equal to plus infinite, the q is also plus infinite. There is no any change in the limitations. So sum of m is equal to minus infinite to infinite, x1 of m, and the sum of p now changes to the q. Follow my students. Q is equal to minus infinite to infinite, x2 of p minus m as a q, x3 of n minus p. What is a p? M plus q. So n minus q minus m. N minus q minus m. Okay, that is equal to sum of m is equal to minus infinite to infinite. Now you can see this one. Sum of q is equal to minus infinite to infinite. x1 of x2 of q, x3 of n minus q. Okay, the two signals we have, that is a y2 of n minus m. Substitute here. Y2 of n minus m. Therefore, x1 of n is a formula is x1 of n and y2 of n. What is a y2 of n? We assume the y2 of n is a x2 and x3. x2 and x3 RHS. Okay, we take the LHS as x1 and x2 with x3. Now what is RHS? x3 and x2 with xn. Okay, some little bit confusion. 2-3 times you can write down, my dear students, then you can understand. Alright, don't go in this integral value, only you have to go for the discrete functions to prove the associative property. Alright. So all the three properties, commutative property, distributive property, and associative property obeys the convolution, obeys all these three properties. Next, fourth property, shift property. See, in the previous class, I briefly explained. Now here the proofs, with the proofs I am explaining, my dear students. Fifth property, if x1 of t with the convolution of x2 of t is equal to z of t, then x1 of t with the convolution of x2 of t minus tau, the second signal is shifted in the convolution itself, my dear students. The second signal is shifted with the t samples and apply the convolution with the first signal x1 of t. The output is also shifted t minus tau. Let us see that one. x1 of t with the convolution of x2 of t minus tau, according to the definition of the convolution. The first signal x1 of tau, second signal x2 of t minus tau. What is the t here? T minus t minus tau. T minus t minus tau. T minus tau. So t minus tau minus t and minus tau d tau. And that is equal to z of t minus tau. Z of t minus tau. So what is the t here? T is nothing but similarly x1 of t minus tau with the convolution of x2 of t. Why I am taking it as a t minus tau, my dear students? See the formula itself saying that is a y of, we'll explain this one. Y of t convolution integral minus infinite to infinite x1 of tau x2 of t minus tau, the t here and here the t, but in this equation integral minus infinite to infinite x1 of tau x2 of t minus t capital T minus tau d tau. So instead of t, capital T, what is the value here? T minus tau. So y of, what is the y, the output? Here I am taking the output is a z. So z of t minus tau. Following? The same thing we got here. Similarly, when the input x1 is shifted, the output is also shifted. The output is also shifted. And if both the signals are shifted, t minus t1 and the t minus t2, what is the output here? The sum of the two signals shifted. Z of t minus of t1 plus t2. Sum of the two signals shifted values, t1 and the t2 here. When any one of the signal is shifted, the output is also shifted with that same sample. But both the signals are shifted with the t1 and the t2. The output is shifted with the sum of the two shifted samples, t minus t1 plus t2. Okay, fourth one. And the fifth property, convolution with impulse. Any signal is convoluted with impulse, same signal will get, my dear students. Because the multiplication with impulse, same signal. Convolution with impulse also will get the same signal. So convolution of signal x of t with unit impulse signal is a signal x of t itself. Convolution of the signal x of t with impulse signal delta of t is the signal x of t itself. Is the signal x of t itself. Following, my dear students. So see the convolution definition saying that x of t with the convolution of delta of t integral minus infinite to infinite x of t delta of t minus tau d tau. What is the definition of delta? Delta t minus tau is 1 for t is equal to tau. T is equal to tau. The same value is 1. In this range of minus infinite to infinite, only we have the one value for the delta. So equal to the x of t on. But if the shifted version of the impulse is there, shifted of the impulse, shifted impulse value. Actually, it is not the x of t, x of tau only. Now the sixth property, see the convolution of signal x of t with the signal impulse delta of t minus t naught. When I am taking the delta t, it is x of t. Delta of t minus t naught is equal to x of t minus t naught. X of t minus t naught, my students. See how it is? With this shifting property, x of t with the convolution of delta of t minus t naught, the output is z of t minus t. But what is the output here? The x only. But with the shifted version of t minus t naught. Okay. Convolution with the shifted impulse using the shifting property of convolution. The definition saying that integral minus infinite to infinite x of tau delta of t minus t naught minus tau, my students. Actually, it is a delta of t minus t naught minus tau. So what is t here? T minus t naught. So the output is x of t minus t naught. So x of tau, that tau is a t minus t naught. Convolution with impulse signal is a signal itself x of t only. Convolution with the shifted impulse is the same signal with the shifting of t naught samples. Same signal means I am saying the x of t. Without shifting, we'll directly get the x of t. With shifting, the x of t is a shifted version of the shifted with the t naught samples. Seventh property, convolution with the unit step. Convolution with the unit step. So x of t with the mu of t. So integral minus infinite to infinite x of tau mu of t minus tau dt. What is the mu of t? Is equal to 1 for t is greater than or equal to 0 and 0 for t less than 0. What is the mu of t minus tau? Is equal to 1 for t minus tau is greater than or equal to 0 and 0 for t minus tau is less than the 0. So forget about the 0 values. What is the 1? T minus tau is greater than or equal to 0 means t is greater than or equal to tau. And tau is less than or equal to t. Okay, less than or equal to t means from minus infinite here. Minus infinite to t, upper limit. Integral minus infinite to infinite x of tau mu of t minus tau d tau. So what is a t minus tau? By substituting the one value, the range of t is tau is less than or equal to t, less than or equal to total the negative real axis with up to the t value minus infinite to the t x of tau, and this value is of 1 in this range minus infinite to t d tau. So the convolution with unit step x of t with the convolution of mu of t is integral minus infinite to t x of tau d tau. Got it, my students? Okay, total is 7 properties. First is commutative property, second one is distributive property, and associative property. Little bit complicated, but you have to practice, my dear students. So 2 or 3 times you can practice, then you will get the property associative, then shifting property, and the fifth one is convolution with impulse itself signal, convolution with the shifted impulse, same signal but with the shifted of t naught samples, convolution with unit simple, the unit step, the signal will get the x of tau and the d tau, but the limitations is from minus infinite to t. Now coming to the correlation, my dear students. This also we already discussed this briefly. Correlation is basically used to compare Correlation is basically used to compare two signals, or it is a measure of the degree to which the two signals are similar. Correlation means comparing the two signals only. After the comparing only, how much it is how much percentage is two signals are the similar, or it is a measure of the degree of similarity between the two signals. And that two signals, how we can measure by using the two types. One is a cross correlation and the other one is a autocorrelation. Cross correlation is between a pair of signals or a sequence. Between a pair of signals means a different signals. One is x1 and the y1 is given by x and y. X and y is given by r x y is r, my dear student. Some textbooks they are giving like this r x y, and some of them they wrote writing that it is r x y is a gamma, actually representing the gamma. Following in RVSP we will get the correlation and autocorrelation like this also, my dear students. Don't confuse, there it is a different and here it is a difference. Concept is the same. Representing a signal is a difference only. Okay, but you have to learn only the RXY of tau and RXX of tau. It is also autocorrelation or R of tau. You learn like this one. Okay. Whenever you are writing into the notes, if anybody is writing the notes, you change this as a gamma as a R capital. Okay. What is the formula? I already told there is a two signals. How we can comparing the two signals? The two signals, if I am taking the x1 of t, and here I am taking the y of t, x of t only, not the x1, x of t and y of t, the two signals. And the two signals, one signal is shifted with the other signal. X of t is a signal. The another signal is shifted with some samples t minus tau samples if I am shifting. Okay, the two signals when I am taking this is a sinusoidal signal like this as x of t, and y of t is shifted with the tau samples. Then again there is a comparison between the two signals as a similarities, identical. After at the receiving side, these are transmitter side. At transmitter side, we send from the signal sinusoidal signal, and at the receiver side, it receives after the delay. How much delay? Tau delay. And there is a similarities, coherence, or coherent. Okay, there is a different names we have. So now the formula becomes of x of t, y of t minus tau, and apply the integral here with respect to the time dt minus infinite to infinite is equal to the cross correlation of r x y of tau. Is a tau here, the tau. The two signals is actual signals we are taking. So when these two signals are equal, they are orthogonal to each other. Okay. When there is a shifting occurs, this is identical with the shifting of the tau samples. There is a similarities between these two with respect to the time. and apply the integral in between the two signals, we'll call it as a cross correlation. Cross correlation definition. So integral minus infinite to infinite x of t, y of t minus tau dt. Okay, take any one is a conjugate here, the conjugate value, or it is a real value means the sum of n is equal to minus infinite to infinite x of n, y of n minus t or the tau. Here it is a, they are taken as a L as a discrete here. In terms of the discrete and in terms of the continuous, integral value is for continuous and the sum is for the discrete. Also, so I told that is a x of t, the y of t minus tau, d tau, not the d tau, it is a dt. Taking off convolution one thing, and the x of is for the direction of positive values, shifting towards right side positive values. If it is shifted towards the negative values, the value becomes of t plus tau, advanced signal y of t dt. Both it is an integral minus infinite to infinite and minus infinite to infinite. Okay, this is also equal to the r of xy of tau, and this is also equal to the r xy of tau is equal to. You can take the convolution here. Not the convolution, this one is a conjugate. Got it? So integral minus infinite to infinite x of t plus tau y star of t dt, shifted lagged parameters is towards the left side for the negative values. Plus is always advanced. The subscript xy indicates that x of n is the reference sequence that remains unshifted in time, and y of n is shifted with L units and L units in time with respect to the x of n. Okay, if you want to fix y of n and the shift x of n, if you want to fix x of y of n and the shift x of n, okay, then r y x. So interchanging, if I am taking as a commutative law is obeys or not. Now you can see the r y of x of L is equal to the tau I am taking for the continuous, L for the discrete, my students. Otherwise, you can confusion, you can take the k also. That is up to you. Sum of n is equal to minus infinite infinite y of n x of n minus L, or sum of n is equal to minus infinite infinite y of n plus L x of m as a second one. If the time shift L is equal to 0, then we get r xy is equal to 0, xy is equal to 0, r yx is equal to 0. The sum of n is equal to minus infinite infinite x of n y of n. Comparing the equation 1 and the equation 2, so you get the equation 1 and the equation 2, we find that x of r of xy of L is equal to r yx of minus L, the folded version of r xy of L about L is equal to 0. Okay, the folded version. Then only the both are equal. You can rewrite the equation as r xy of L is equal to sum of n is equal to minus infinite infinite x of n y of L minus n minus of L minus n. In that only, so both are equal. Otherwise, both are not equal. So the correlation not obeys convolution. Like convolution, the correlation is not obeys the commutative property. Like convolution, commutative property is not obeys in the correlation. Okay, r x y of tau is not equal to the r y x of tau when is equal Rxy of tau is equal to Ryx of minus tau. Okay, the change of the tau in the continuous, my dear students. Here it is a discrete. I explained in the previously the proof also in the continuous time only. Here it is a discrete. They explain the discrete form. Got it? Then autocorrelation. Autocorrelation is itself, it is a correlation of the sequence within itself only. Rxx of L is equal to Rxx of L is equal to sum of n is equal to minus infinite x of n minus L. Or is a positive values, negative values towards the direction of negative, and these are towards direction of towards positive, and it is towards the negative values. So n plus L minus of minus L minus students here. So Rxx of L is equal to x of n plus L into x of n. If the time shifted L is equal to 0, then Rxx of 0 is equal to sum of n is equal to minus infinite. Both, why I'm taking the x square, here it is a star and this is a star. So squared magnitude of x of n. When L is equal to 0, it becomes of x of n and x star of n. And L is equal to 0, x of n, x star of n. Squared magnitude of x of n is equal to the energy signal also. Following. At E is equal to R of tau at tau is equal to 0. Rxx only. Or otherwise you can write it as R of tau also. Okay. Autocorrelation signal Rxx of tau is equal to x of t, the integral x star of t minus tau, or x of t plus tau, x star of t is for the direction of positive values and is a direction of negative values. For real value, it is a complex. For real value, there is no any star function. For positive values, the direction of positive and it is the direction of negative values. Got it, my dear students? So properties of cross correlation function for energy signals. For energy signals, is already we proved that it is Ryx of tau is equal to Rx of xy of minus tau. Okay, Ryx y of t plus tau x of tau dt, and that is equal to integral minus infinite t plus tau is equal to, we can write as any one value, y of t is equal to x of t minus tau dt, and x of t minus tau y of t dt is equal to Rxy of minus tau. For complex valued signals, Ryx of tau is equal to Rxy star of minus tau. Got it? See, these are directly, if I am taking that is a t plus tau is equal to p. Okay, in this equation, so integral minus infinite t plus tau is equal to p means x of p, y of t is equal to p minus tau d, t minus tau p, and what is a t? T minus tau is equal to p means the tau is a constant and the t and the p is a variables. So dt is equal to dp. So dt is equal to dp. Now the p value. Here the dummy variable only. So integral minus infinite. Now it becomes of x value is x of p, or nothing but is x of t, y of t minus tau dt, as I'm taking the t values. So here see the x of t plus tau y of t dt and x of t y of t minus tau dt. They're interchanging the values. But here the t plus tau and it is a t minus tau. The t plus tau and the t minus tau. So y of t, it becomes of xs becomes of y of t, and y of t plus tau, and it is a y of t, x of t minus tau. So changing it is y of t plus tau, you can take x of t minus tau, and x of t becomes is a y of t. Okay, but both are not the same. For the negative direction, we'll get the positive values, and the positive direction there is a negative values. So for r x y of tau is equal to, when I'm changing the y to x, it is a minus value, minus tau. Got it, my dear students? Then another property, when tau is equal to 0, then the signals are said to be orthogonal over the entire time intervals. And integral y of t, the y star of t dt is equal to 0. When this value is for cross correlation. Okay, for cross correlation, my dear student. These are properties for the cross correlation of energy signals. X of t, x y star of t dt is equal to complex orthogonality in complex function is equal to 0. And cross correlation of the periodic signals. Periodic signals means power signal, my dear students. What is the power signal? The definition is the same, but with the limitation of the t. Limit t tends to t infinite 1 by t, the integral minus t by the t by 2. The remaining is all the function of energy function. X of t, y star of t minus tau dt. And similarly, yx is equal to limit t tends to infinite y of t x star of t minus tau dt. So actually, don't write this a y of x is a tau. Is similar, because it is both are not equal, my dear students. It is wrong actually. Is there any statement here? It is up to this x of t and y star of t minus tau, or you can write as a limit t tends to infinite 1 by t. See here the 1 by 2t limitation is a minus t to t. 1 by t, it is a minus t by to the t by 2. That is up to you. Integral minus t by to the t by 2. You can write this as x of t plus tau and y of t star dt. Now it is equal. This is for negative on the negative positive direction, and this for the negative direction. Okay, t plus tau. Got it, my dear students? See the x of t minus tau, and here the x of t plus tau, and take the star here. The other properties of the periodic signals, the rxy of tau is not equal to ryx of tau. It is equal of rxy of tau is equal to ry of minus tau minus tau. And the cross correlation is executes at origin tau is equal to 0. Rxy of 0 is equal to 0 is an orthogonal, said to be orthogonal periodic signals. Got it? So this is all the properties we already discussed. Now I am again, some of them is a briefly and some of them is a fully I am explaining again. So some of other properties we have here, the properties of autocorrelation function, these also we already seen there. And these are the another properties. And the difference between the cross correlation for the energy signals. And these also the one of the properties. Now in the tomorrow class, we can see this, the problems on the autocorrelation, the cross correlation, 1 and the 2 examples we have. In the tomorrow class, we can see the 2 examples of correlation, autocorrelation and the cross correlation. Okay. So any doubts? Thank you.